morning, students. In today's class, we shall be solving some questions from the NCERT Miscellaneous Exercise of Determinants. Okay, so let's start with the first question. Prove that this determinant is independent of theta. Some determinant is given, representing it by delta. Elements of the first column then elements of next column and the third column. We are showing that this is independent of theta. Okay, so let us start with the expansion. So I will once again expand along the first row. So delta is cos into minus x square minus 1 minus sine theta multiplied by minus x sine theta minus cos theta plus cos theta into minus sine theta plus x cos theta. Simplifying, we get these terms. So here these two terms cancel out. Okay, look at this term and this term. We can take x common. So minus x cube minus x. So in these two terms we take x common. And this is a trigonometric identity which is equal to 1. So plus minus x will cancel off. We get minus x cube. So the value of delta is minus x cube, and this we know is independent of theta. Okay, now next question number 2. Without expanding the determinant, prove that this determinant is equal to the determinant on the right hand side. So it is mentioned here that we are not expanding the determinant. So if we are not expanding the determinant, then this is where we can work upon. So we'll start with the left hand side determinant, and in the left hand side what we shall do here is, you can see here we need terms like a square and a cube. So let us multiply the first row by a. Alright, so in the left side, what are we doing? Let's write down row operation wise. So we are multiplying r1 by a. Let's also multiply r2 by b and r3 by c. So if we are representing the left hand side determinant as delta, so you know this property, when a row is multiplied by a constant, the determinant also gets multiplied by the same constant, right? And now on the right hand side, we obtain a square, a cube, abc, first row, multiplying second row by b, we get this, and this is the third row. Now in this row you can see that from the column we can take ABC common. So taking ABC common from the third column. So here left side is ABC times delta. On the right side we have taken this common, ABC. So we get A square, B square, C square. Here is A cube, B cube, C cube, and this. So these constants finally get cancelled off. This is what we have obtained. Now this has to be converted to this, which basically means shifting of columns. So let us say shift the interchange first and second columns. So this is again one property which tells us that if we interchange columns, the determinant will now change its sign. Alright, so negative sign here, first column, this is second column, third column, and the second column does not change. Again, we can interchange these two columns. So in the next step, we are interchanging the second and the third column. When we interchange the column, the sign of the determinant will change. So it becomes positive. So here the first column remains the same, and the second column is now A square, B square, C square, and the third column A cube, B cube, C cube. So you can see we started with the left hand side, which is delta, and we have shown that finally delta is equal to the right hand side. So we have not anywhere expanded, we have simply used various properties of determinants. So next we are doing here question number 3. Evaluate this determinant. So the determinant is delta, and it is cos alpha cos beta minus sin beta sin alpha cos beta. Here we have cos alpha sin beta cos beta and sin alpha sin beta. The third column is minus sin alpha 0 cos alpha. So the question is to evaluate this determinant. So here for the evaluation, since the second row has got 1 0, I will prefer to expand along the second row. Now when you expand along the second row, this element will change its sign and this will change its sign. It is 0 because it makes no difference. So expanding along second row. So this will change its sign, sin beta multiplied by cos square alpha sin beta plus sin square alpha sin beta. Next element cos beta. This is to be multiplied by cos square alpha cos beta plus sin square alpha cos beta. So let's multiply cos square alpha sin square beta plus sin square alpha sin square beta So here you can see in this bracket we can take sin beta common. So we have sin square beta cos square alpha plus sin square alpha. Over here we can take cos beta common. So we get cos square alpha plus sin square alpha. Again from basic trigonometry, you know this result is 1. This result is 1. So we have sin square beta plus cos square beta, which turns out to be 1. So this determinant is equal to 1. So next I'm taking up question number 5. Solve this equation if a is not equal to 0. So this information is given. A is not equal to 0, and then we have to solve this determinant. And this determinant is equal to 0. So if you look column wise or you look row wise, you get to know that the elements are same. So I'm performing this kind of an operation, adding all the elements of the corresponding elements of the rows. We could have performed a column operation also. So the determinant delta, the first element will be 3x plus a. Here also 3x plus a, 3x plus a. The second and the third row is the same. So taking 3x plus a common from the first row, we have 3 1s. Now the moment we get 3 1s, any two can be converted to 0. So suppose I am performing this operation C1 as C1 minus C3. I'm converting this into a 0 and I want to convert this into a 0. C2 minus C3. Then the first column C1 minus C3 0 and 0, this minus this minus a. Then C2 minus C3 is 0, a minus a, and here is 1x, x plus a. You can perform the expansion along the first row, the first column, or you can take a is common from the first and second column also, so the way you want to do it. So suppose I am directly expanding along the first row. So we obtain here 3x plus a. Expansion along this will give us 0 plus a square. So this is the value of delta. Now here it is already mentioned that this delta is equal to 0. Now since delta is equal to 0, this means that 3x plus a is 0 or a square is 0. Since we are given that a cannot be equal to 0, so obviously it means that a square is also not 0. So only this factor is 0, and hence value of a is minus a by 3. This also means that x cannot have a value equal to 0 because a is not 0. So this way, using properties of determinants only, we have used row operations, column operations, and we are able to find out value of x. So now let us solve question number 4. Question 4, if a, b, c are real. So we are given constants a, b, c are real numbers, and we have to find out factors of this determinant. We have to find out factors of this determinant and show that if the determinant is 0, then either a plus b plus c is 0 or a is equal to b is equal to c. So here, once again, looking at the elements of the determinant either in a row or in a column, we see that elements are same. So performing a row operation, r1 plus r2 plus r3, or we could have performed a column operation. The elements of the first row would become twice of a plus b plus c. And the second row remains the same, likewise, The third row does not change. The first row elements are all identical, so that means we can take a factor twice a plus b plus c common, right? So the first row elements are all ones. Here is c plus a plus b, a plus b, b plus c, b plus c and c plus a. Now here I'll just suggest that because it is given that delta is equal to 0, so here instead of delta we can write down 0 only. Okay, now the moment you get 3 ones, convert any two of them into zeros. So suppose I'm converting this into a 0 and this into a 0. So what operations are possible here? I'm performing an operation like, let me do this side. C1 as C1 minus C3 and C2 as C2 minus C3. So left side is 0. On the right hand side, the determinant C1 minus C3. So this is 0. This minus this will give us A minus B. This minus this will give us B minus C. Likewise, C2 minus C3. This is 0. This is A minus C. And this will be B minus A. And the last column is this. So now expanding along the first row. We get A minus B into B minus A minus B minus C into A minus C. So now I will write down something here which is equal to 0, because we usually are in a habit of writing 0 on the right hand side. So performing this multiplication, AB minus A square minus B square plus AB minus AB plus BC plus AC minus C square. So one of the factors gets cancelled, and over here you can see that the square terms are all negative. So from this bracket I am taking a minus sign common. Alright, so let me write down here, taking minus 1 common, we get this. Now inside we have the square terms as positive terms and the product of the terms as negative, like this. So now here you can see that we have got basically two factors. One of the factors is, I'm writing it as minus A plus B plus C is 0, and 2 I'm associating with this factor 2 times this factor is 0. So this factor is 0, one condition obtained. So that means the second condition has to be obtained from here. What we do here is multiply each term by 2. So we get 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ac, which is equal to 0. Now we are going to rearrange the terms. How do we rearrange these terms? Let's see. There is a term like minus 2ab. So for minus 2b, I'll take one a square term from here and one b square term from here, which in the next step can be written as a minus b whole square. Alright, likewise, next pick up this term which is minus 2bc. It has got bc terms, so one more b square can be taken from here, one c square can be taken from here, and this can be written as b minus c whole square. Now see what is left. This term is left, minus 2ac. We are left with an a square term and a c square term, which is equal to 0, and the third bracket is an identity, which is a minus c whole square equal to 0. So we are getting sum of 3 squares is 0. What are ABC? It was given initially to us that ABC are real numbers. And we know that whenever we add squares of real numbers, we get positive numbers. So sum of three positive numbers cannot be 0. It can be 0 only when each of these square terms is equal to 0, which means A is equal to B. Likewise, from this you get B is equal to C, from here A is equal to C. So this way I have written this result kind of directly. So the second condition this way helps us obtain that all the three numbers are real. In that case, the determinant can be 0, or if they are not 0, then sum of the real numbers should be equal to 0. So this question is an important question, and these types of questions have been asked in the board exams for 6 marks. So next we'll take up here question number 12. You can mark this as an important question because this question has been asked in board exams. So using properties of determinants, prove that this determinant, which has first column x, y, z, second column x square, y square, z square, and the next column is 1 plus px cube, 1 plus py cube, 1 plus pz cube, and this is equal to 1 plus px y z, x minus y into y minus z into z minus x, where we are given that p is any scalar. When we say a scalar quantity, we mean to say that this is a non-zero real number. So when we are using properties of determinants, there are various properties, and then it depends out of the 4 given factors on the right hand side, which one do we want to choose and perform first. As you can see here, you have factors like x minus y, y minus z, which can be easily obtained by performing operations like r1 minus r2, right? But I'm going to do this question in a different way, and there are various ways of solving such questions. I'm trying to solve it in a different way. So what is that different way? Instead of choosing these factors, I'm choosing this factor. How to get this factor in the first step, or maybe in 2-3 steps. So one of the properties tells us that if the elements of a column are expressed as sum of 2 terms, then the determinant can be expressed as sum of 2 determinants. So if this determinant is delta, then this delta can be expressed as sum of 2 determinants. The first column is same, second column is also same, and the third column here is 1, and here it is px cube, py cube, pz cube. So I'm simplifying this one first. As you can see, you can take x common from the first row, so writing x here. You can take y common from second row, you can take z common from the second row, right? So after taking these common, what do we get? 1 x, and from here also we have taken x, so we are left with px square. Then here we have taken y common, so we are left here with 1y py square. Over here z is common, so we get this. In the same step, if you notice, there is a factor p which is common in the third column. So I am taking this p also common from here in the same step, like this. Alright, so that means from this step we have taken 4 things common. X, Y, Z common from the 3 rows respectively, and p common from the third column. So this we have done in one step. And now look at the steps here. The first column is 1. Here the third column is 1. That means we can make changes in this one. So what we are performing here is, you can write down here, interchanging column say 1 with column 3. This operation is only for the first determinant. So when you are performing this kind of an operation, you know the sign of the determinant will change. So the first column is 1. This is second column, and the third column x, y, z plus this determinant. Again you notice that ones have been obtained, next we need x, y, z here. So we are again interchanging the second and the third column. The moment we change the second and third column, the determinant will change its sign, it will become positive, and hence we obtain this x square, y square, z square, and over here we have p, x, y, z and this determinant. So here, like we have mentioned, this operation to be performed on the first determinant. Likewise, if you want to write down here, so you can write down here that take x, y, z, p common from the first row, second row, third column respectively. Okay, so we have got this. Now when you look at these two steps, you see that the determinant is the same. So we can take this determinant common, and one of the factors that we can obtain here is, if we take these two determinants common, then a factor of 1 and a factor of a term p, x, y, z can be taken from here. So this way we have obtained the first factor here. Okay, now there are 3 ones here. Think this way, that 3 ones, out of 3 ones, 2 ones have to be converted to 0, or if you're looking at this factor, you can find out x minus y by performing an operation as r1 minus r2. So here we get, we are representing this by delta, alright. So delta is now 1 plus p, x, y, z. So r1 minus r2, this is 0, x minus y, x square minus y square, writing in simplified form is this. In the same operation, we can also get y minus z. So if we perform an operation like r2 is r2 minus r3, then changing the second row, we obtain this y square minus z square, which is y minus z, y plus z. So 2 rows have been changed, and the third row is the same. Now because the first column has got 2 zeros and 1, so we can expand, but here before expansion we'll take something common from the first and second row. So let us take x minus y and y minus z common from the first row and second row respectively. So one of the factors was this, which we had already obtained. Now we are getting x minus y from the first row, y minus z from the second row, and what do we get? 0, 1, x plus y, 0, 1, y plus z, and 1, z, z square. So now we can expand along the first column. So expanding along C1, delta is 1 plus p, x, y, z into x minus y into y minus z. So expansion along this will give us y plus z minus x minus y. So plus y minus y will cancel. So the third option, or the third factor, is also obtained, x minus y, y minus z into z minus x, which is equal to the right hand side. So as I said, there is no unique way of doing it. You can start the question by taking these factors. I have chosen this factor, which can be obtained first using a property where the determinant can be expressed as sum of 2 determinants. Okay. So next we are trying out question number 14. Again, using properties of determinants, show that this determinant has a value equal to 1. 6p plus 3q. So let's start with the left hand side. And in the left hand side, looking at these elements, because there is a 1 here, so I would like to convert this into a 0. So it can be done as R2 as R2 minus twice R1. Okay, so performing this operation, what will we get? The first row is same. This minus twice of this 0. This minus twice will give us 1. This minus twice will give us 2 plus p. Okay, likewise, this also can be converted into a 0 by using this row operation, R3 minus 3 times R1. So 3 minus 3, 0. This minus 3, this minus 3, 7 plus 3p. This is what we get. And now let us expand along the first column. So what do we get? 7 plus 3p minus 3 times 2 plus p. So 7 plus 3p minus 6 minus 3p gives us 1, which is equal to the right hand side here. And next we look at question number 15. Question 15, the trigonometric ratios given: sine alpha, sine beta, sine gamma, cos alpha, cos beta, cos gamma, cos alpha plus delta. This symbol we are reading as delta. So this is cos beta plus delta, and this is cos gamma plus delta. We have to show that this determinant is 0. So here what I am going to try out is expand this row, this column, using trigonometric ratios. As I've said, there are different ways of solving the question. This is one of the methods. So cos a plus b will be cos a cos b minus sin a sin b. And this term is cos gamma cos delta minus sin gamma sin delta. And here if you perform an operation in the first column as, or let's do it in the second column. I've chosen the second column because these cos alpha beta gamma terms are in the second column. So I'm multiplying the second row columns by cos delta C2, and from this we are subtracting sin delta times the first column. So we are making changes in the second column. So first column remains the same. Second column, multiplying this by cos delta, so we have cos alpha into cos delta. Here is cos beta into cos delta, cos gamma into cos delta, minus sin delta. So here is sin delta into C1. C1 is this. So this is the first column, here is the second column, and the third column is exactly same as the second column. Cos beta cos delta minus sin beta sine term, sine delta. Here is also sine delta. This is cos alpha, cos delta minus sine gamma, sine delta. So here you can notice that the second and the third columns are identical. Therefore, the determinant is 0. So let me explain it again. We have used trigonometric ratios formulas here. So this is what we get. When we write it down here, we notice that each of the cos term is being multiplied by cos delta. So we know the second column is to be multiplied by cos delta. Over here also you can see that you have sine delta. You are multiplying by minus sine delta. What are you multiplying? Columns of the elements of the first column. So this is what I have done, minus sine delta C1. This is how we have made changes in the second column. Once we perform this operation, the second column becomes identical to the third column, hence the determinant is 0.